I don't have anything to raffle off, but it looks like a previous speaker left a really nice power supply to a Macintosh, so I will be auctioning this at the end of the speech. So, or does this belong to you? Would you like it back? There you go. I want to talk about the single most important design guideline that I know of for writing software. I do not care what the software does. I do not care what the software is supposed to be doing for people. I don't care whether people are using it or machines are using it. I don't care what language it's written in. It is the single most important design guideline that I know of. I will get to the punch right away. Number one guideline is make interfaces easy to use correctly and hard to use incorrectly. And the reason I believe that that is so important is because we spend a giant amount of our time dealing with interfaces, either designing interfaces or using interfaces, either as software developers or as users of software. So the thing is, there's lots and lots of interfaces, and I think we often forget just how many there are. So there are two basic classes of interfaces. To many people, when I mention interfaces, they think of end-user interfaces, or as I like to think of it, interfaces that are encountered by everybody, because software developers are people too. So we have GUI interfaces, we have gesture-based interfaces. In some cases, we still have command line interfaces. These days, we have speech-based interfaces. These are interfaces used by everybody, which means they have to be designed, they have to be implemented, they have to be used. But within the realm of software development, there's another kind of interface. Those are the interfaces that are encountered by software developers. We usually call these APIs. So we have library interfaces. They have interfaces too. We have module interfaces, we have class interfaces, we have method interfaces, we have function interfaces, we have generic interfaces, we have template interfaces. We are either using these interfaces as software developers, or we are designing these interfaces as software developers. And if we're not working directly on the interfaces used and implemented by software developers, then we're probably somehow involved in the interfaces that are used basically by everybody. If you are not involved in some way in either designing, implementing, or using interfaces, it is difficult to imagine why you are here. Now, as I was looking over the slides for my talk, I realized that for a keynote talk, especially at the end of a conference, you really need to have something which can grab people's imagination. It needs to be engaging. And in particular, I've noticed that really good keynotes have great visuals. I'm a C++ programmer. We don't really do great visuals. So I said, but what can I do to liven up my talk short of going to Google and taking a bunch of images? The problem I have with that is I can't get them licensed in the amount of time. And then it occurred to me, I was a tourist in Riga on Monday and Tuesday, and I have some pictures. They have nothing to do with the talk, but they add visual appeal. And even if you don't like the rest of the talk, at least it will give you something pretty to look at. I take as a point of departure that the people using interfaces, whether they are regular people or they are software developers, that they have certain traits in common. The first one is they have some experience with software. Most of us are not dealing with people who have never dealt with software ever before. So I think that's a reasonable assumption. I think it is a reasonable assumption to say that they are willing to read at least a little bit of documentation. Not a lot of documentation, but at least a little bit of documentation. And most importantly, and I think we always need to bear this in mind, they want to succeed. People who use interfaces want to get something done. They do not want to fail. They do not want the wrong thing to happen. They want it to do what they desire. And my feeling is, if someone is using an interface that you designed, or an interface that you implemented, they're smart, they're motivated, they have some experience with software, they're willing to read a little bit of documentation, they want to succeed. If they are bringing all those things to the table, you can't ask them to bring anything more. They're doing everything that they can reasonably do to make the interface work. And what that means is if for some reason, if they do not achieve their goal, if they do not use the interface correctly, then what that means is it's your fault. It's not their fault. You cannot blame the user. You cannot blame the caller. They're trying to do the right thing. If they're failing to do the right thing, it's because there's something wrong with the interface which is permitting them to make an error that should not be permissible. What this means is that software should be designed and implemented to be easy to use correctly and hard to use incorrectly. That has some consequences. If an action is possible, either through an end user interface or through an API, if it's possible, it should do the right thing with very high likelihood. And if an action is unlikely to do the right thing, if it is likely to lead to someone failing, it generally speaking should be excluded through the interface. It shouldn't even be possible to do it. What we want to shoot for as a software development industry is what Rico Mariani calls the pit of success. The idea of a pit of success is if you get up and you trip and you fall on your face, you accidentally do the right thing. You didn't have to think about it. By default, all of the forces are pushing you in the right direction for you to succeed. That is the goal of interface design and implementation. And it doesn't matter whether it's an API or a user interface. So what I want to do is spend the rest of this presentation talking about general and then more specific ways that we can implement interfaces that will be easy to use correctly and hard to use incorrectly. We will start with the most general principle, which is what is known as the principle of least astonishment. Everyone who comes to use an interface, they have some background, they have some expectations. When they use the interface should not astonish them. They should not be surprised unless it is a pleasant surprise. Every user brings some kind of expectation to the interface. The expectations in many cases, to be perfectly honest, they are just guesses. People are guessing. What does the API do? What parameter should I pass? What happens if I make this gesture? What happens if I speak the following command? People are guessing as to what's going to happen. Your job as interface designers is to maximize the likelihood that they guess correctly. If users can do something, it should do what they expect. As I've mentioned, this applies both to end user interfaces as well as to APIs. If users know what they want to do, it should be pretty straightforward for them to figure out how to do it. So I want to talk about some examples and mostly counterexamples in professional software, which runs counter to the things I've been talking about. And what I find is that people who work with software all the time get so used to its quirks that they don't even see them any longer. So I don't know whose genius idea it was that if you want to shut down Windows, the command to give is start. And people in the Windows community have done this for over a decade now. It does not occur to them, this is completely stupid. Now, as it turns out, I have read a blog entry by the designers at Microsoft talking about how they came up with the magic start button, about the process they went through, about the user groups that they had, and what it boiled down to was everything else we tried was worse. That was the rationale for choosing the start button, was everything else was worse. We are really not doing very well as an industry when we say, well, it's the least worst choice we could come up with. And what I find truly amusing about it, so the start button, Windows 95, 20 years ago. And what's the biggest complaint about Windows 8? It doesn't have a start button. There is an important lesson here. If you are so fortunate as to design an interface that becomes so comfortable to people that they're still using it and clamoring for it 20 years later, you would like it to be an interface that you are proud of. Sometimes you make choices that have really long-lasting effects.
It's back in Windows 10, though.
The start button is back in Windows 10? Yeah. It's nice to know that by default we can have the 1995 user experience. Makes me feel much better. I don't want to just pick on Windows. I want to pick on everybody, as you will see. So from various versions of the Mac operating system, if you wanted to take a CD or a DVD, you drag its icon to the trash can. I'm not a Mac user, so I have no idea whether they still have this interface. What I can say is at the time that I was exposed to this interface, I happened to be in graduate school at the time. And when I wanted to, as it turns out, drag a floppy disk out of the machine, those of you who don't remember floppy disks, you are so lucky. Nevertheless, I wanted to eject a removable disk from the machine, so I said to my friends, so how do I get this out of the machine? And they said, you drag it to the trash. And I said, you are lying to me. It cannot possibly be the case that remove removable media is the same command as destroy this file. But somebody thought that was a really good idea. So this is something a little more subtle. This happens to be from Windows XP. Now, right about now, you might be thinking, oh goody, it's the historical trend trip where we talk about Windows XP, which is so old it has been discontinued, and Mac OS, and I'm talking about floppy disks. I will be showing you some old examples. I will be showing you some new examples. The start button is still around, apparently backed by popular demand. But it turns out that in Windows XP, Microsoft came with two different choices in the operating system for font size. Two choices, normal and large. Supported by the operating system, normal font size, large font size. Being young and foolish, I decided I would experiment with the large font size because the small one, the normal one, was too small, in my opinion. And what I discovered was that if you selected the large font size pre-packaged by Windows XP, the manufacturer of the operating system, nothing worked correctly. Nothing worked correctly. So you can notice that we have an abrupt change here in the baseline of the text. This is in Excel at the time. The text is not lining up. If you look over here, the word here is sponge, but you can't see it because the descender on the P and the G are missing. Notice that the left-hand side of C in CD is missing. Nothing worked if you chose large size fonts. I was astonished. I'm going to be giving a lot of examples to you. Some of them will seem kind of silly. What I want to remind you is every single example I am showing you is from a professionally designed and implemented shipping production artifact. Now, I'm going to be talking about both APIs and user interface things, so they're not always necessarily products, but every single thing I'm showing you, professional software developers said, yep, that's good, let's ship that baby. And their manager said, yes, that's what we want to be known for. So this is an installation counterexample. This happens to be an API thing, but this is something developers occasionally have to deal with. This is from Qt 4.8. So I was installing the software onto my Windows machine, and I am sorry that I use a Windows machine, but there you have it. And from the installation instructions, the install path must not contain any spaces. Excuse me? On an operating system which has program files as a predefined directory and my documents as a predefined directory, I can't have spaces in my installation path name? This is because the software was designed on Unix where spaces are legal but nobody uses them in path names unless you really want to mess up software. And having written it for Unix, they said, great, we'll port it to Windows. Except the porting process did not include taking into account that on Windows, things are a little bit different. For example, on Unix, we don't use spaces and file names are case sensitive. On Windows, we do use spaces and file names are not case sensitive. These are not the same worlds. When you go from software written from one world to another world, the kinds of things that are going to astonish your users will change. It is your responsibility to adapt the assumptions that you make to the expectations of the people who are going to be using your software. Just because it worked perfectly well and was well designed for one group of users does not mean it will be suitably designed for a different group of users. This is an example from a blog post from 2010. It's from a handheld device. It has to do with selecting the next month in a couple of different travel sites. So the one on the left, this happens to be Expedia. The one on the right, this happens to be Kayak. Now this is 2010, which seems like a long time ago, but for perspective, the iPhone was introduced in 2007. And the reason that's important is because that means that 2007 we can think of as the beginning of the mass introduction of gesture-based interfaces and multi-touch devices. So it turns out that if you're in March in Expedia's app, smartphone app, and you want to move to the next month, the only thing you can do is touch right here. Now, in Kayak's version, you can also touch right here. So in both cases, you can touch a button. But you know, it's a mobile device. The screen is small, fingers are fat, you're on a train, it's moving, it's hard to hit the right location. This is not a desktop PC. So it turns out that for Kayak, you also can swipe, and you can actually see the month is changing here. And the reason I'm pointing this out is because for the people who did the Expedia app, it's very clear they took the notion of a desktop application and they ported it to a little screen. Whereas the people doing Kayak took into account it's not the same kind of experience that people are going to be expecting. So for somebody who's used to a gesture-based interface, and by 2010, that was most mobile users of smartphones, the fact that they can't swipe here would astonish them. Some interfaces are so bad, it's really difficult to describe exactly what's wrong with them. So this one was sent to me. Professional software artifacts. People paid money for this software. With any luck, not a lot of money. This is a calendar application. So you've got a calendar application. Let's suppose you have a meeting that is scheduled for every Monday. But let's suppose that on Monday, the meeting's not taking place. Maybe it's vacation, maybe the boss is sick, we don't know. It's not going to take place on Monday. So you say, great, I want to delete this meeting. Now, this is an ambiguous request. The reason it's ambiguous is because the question is, do you want to delete it just this one Monday, but it should still occur every Monday after that? Or should the meetings on Monday always be canceled? Maybe they've been moved to Thursday or something like that. So when you give the command in this charming piece of software, it says delete this single item, no to delete all. And then it continues, of course, in German, abzubrechen tippen Sie auf X. Now, what I like best is it says no to delete all, and there's no no. This is bad in so many ways. It makes a great example, but it astonishes its users. It is remotely possible that the person using this actually doesn't speak German, although you can see that it's got the abbreviation, so this is probably the German version, in which case they might wonder why they have to know English. Bad design, but bad design because it astonishes its users. So this is a different kind of astonishment. This one was sent to me very recently. Now, if you take a look at this, this is the mobile version of reading Slate online. Slate publishes various kinds of articles. Basically, you read things at Slate. It's a magazine. This is not a complicated task. It should not be difficult to take words and put them into a rectangular screen. That's what they've done. They've taken words, they've put them into a rectangular screen. Now, what's interesting about this is the way that it's laid out. So you're reading down, it looks like this is the end of the article. At the end of the article, we've got the comments, here are the top comments, there's that many comments. But it turns out that's not what this interface does. It turns out that for whatever reason, the designers have decided to float the top comment into the middle of the display, presumably to, I am not making this up, presumably to get you so excited that you'll keep reading. So it turns out this paragraph here is not a comment. This is a continuation of the article. And what's interesting about this is that if the comment happens to float to just the right spot, in particular to the end of a paragraph, where a reader could think, oh, that's the end of the article, they will not read to the end of the article. Which means this is an interface, this boggles my mind. It is an interface that is easy to use incorrectly, and the only thing we're trying to do is read text. They've managed to come up with a way to make it difficult to know when you've reached the end of an article. That is a fairly impressive accomplishment from the point of view of interface design. What you want to do is avoid gratuitous incompatibilities with the surrounding environment. You want to take advantage of the things that people already know, the things that people are already used to. Unless there is a compelling reason to differ from what people expect, go with the flow, give them what they expect. Now, in some cases, you will have a compelling reason. I am not ruling out the possibility of changing the way that people work, but there better be a good reason for it. You want to offer a natural syntax. And let me talk a little bit about APIs. So in an API, for example, you want to use the expected operators and the expected function names, and that varies from programming language to programming language. If you take the very simple common task of determining, is this the same as this? If x is equal to y, a pretty common thing programmers want to check for. So, well, in C++, you overload a function called operator equal equal. In Java, you overload an operator called equals with a lowercase e. In C#, an equals with an uppercase e, as well as operator equal equal. The fact that they are slightly different is unfortunate, but that's what happens when you adapt to different user communities. Different communities have different norms, they have different expectations. Your job as an API designer, as an interface designer, is to adapt to the conventions that exist, not to try to make people fight them. You also want to offer intuitive semantics, make things behave the way people expect. So in APIs, for example, I give people the advice, when in doubt, do as the built-ins do or do as the standard library types do. If you're designing a brand new type, and if you ever type the word class, you are defining a new type. And if you are defining a new type, that type is going to have some behavior. If there is not a good reason to differ, you want the behavior to be exactly the same, either as the built-in types or as standard library types. It should behave the way people will expect it to behave. People should not have to memorize your API for some custom reason. In user interfaces, try to have mouse clicks, keyboard shortcuts, gestures mean the usual things. Because I'm a Windows user, this means I am supposed to suffer. But it is nevertheless frustrating that when I go from application to application, the keyboard commands don't necessarily map to one another, and there's no good reason for them being different. Nevertheless, telling you to avoid astonishing people, it's general advice. It sounds nice. I get to show cute pictures. But that won't help you when you go back to work tomorrow to try to write better software. So what I want to do is give you some specific advice. I am going to start with the most basic thing that anybody who has ever developed software learned in their very first programming class. The very first thing you learned was choose good names. And the very first thing you learned after that was all the good names have already been taken. All the good names were used up in the 1960s by people programming in Fortran. The good names are gone. But names are the interface, especially when it comes to programming. The name of a class, the name of a function, the name of a parameter, the name of a template, the name of a file. That very first impression that people get is based on the name. And if the name misleads them for some reason, it will be very difficult to recover. This is why choosing good names is important. Yes, it's difficult. Yes, the good ones have already been taken, but it doesn't mean that you still don't need to choose good names and give it a lot of thought. Because it is so important, I'm going to remind you of so many things that need to be named. Libraries, modules, namespace generics, and templates, they all need to be named well. Classes, functions, enums, typedefs, they need to be given descriptive, meaningful, usable names. Members, attributes, properties, methods, constants, objects, variables, parameters, messages in message-based systems. I'm not done. Menu entries, dialog options, environment variables, configuration files. These are the things that people have to talk about by name. Now, there are some people who believe that Unix has the best possible names in the world and think that a great name is .newsrc, but that is not necessarily what everybody else is going to think. So here is a counterexample that actually goes along with what the platform normally enforces. This happens to be from Acrobat 9. So I open up a PDF file, I make some modifications to the PDF file, and then I decide that I want to exit Acrobat. So Acrobat wants to tell me that I've made some modifications to the file, and it wants to know whether it's okay and whether I should save these things. So it says, do you want to save the changes to your file? Yes, I know what that means. No, I know what that means. Cancel, I never have any idea what that means. Now, it turns out what cancel means is cancel the request to close the program and go back to doing whatever you were doing. But I can never remember the difference between no and cancel, and it is kind of important. But we have other crack interface designers at work at this problem who are not compelled to follow convention. So in OpenOffice, we have a different dialogue. Same problem. What happens? They say, do you want to save your changes? Save. Well, it's not the same as yes, but I wasn't really confused about yes. Do you want to save your changes? Discard. Well, it's a nice word, but frankly, no was not that confusing. The one that bothered me was cancel. And that's what they're using the same thing. Now, what I find odd about this, these are desktop applications. We are not talking a 5-inch, 4-inch, 3-inch screen. We are talking a 21 or a 26-inch screen. Don't you think that by 2010 we could stick 2 words maybe on this button here? It's not really so necessary any longer that it look exactly like it looked when 800 by 600 was the standard monitor resolution. So one possibility here is to really think outside the box and put more text here. But there are other ways to solve this problem. For example, one could imagine that instead of giving you a dialog at all, Adobe would just silently change the file. Silently save the file. Wouldn't ask you, it would just save it. So it'd be there on disk somewhere, you wouldn't even necessarily have to know about it, until later you went, where is that document? And then you go, oh, as it happens, I thought you might want it, I saved it for you. Now, this would lead to other user interface problems or challenges, such as how do you tell people that it's been saved and how do you help them find the appropriate document? But one of the things I find is that if you have a user interface challenge that is making it difficult for people to do the right thing, try to come up with an alternative design that makes the problem completely go away. So there's more than one way to solve the problem, and rewording the button is not the only thing that is possible. There is this notion in the interface community of the gulf of execution. The gulf of execution is the distance between what you want to do and the action you must take in order to get it done. The larger the gulf of execution, the more difficult it is for you to do what you want to do. The smaller the gulf of execution, the easier it is for you to do what you want to do. As interface designers, our goal is to minimize the gulf of execution. We would like that gulf of execution to turn into the pit of success. So I've been talking about API design and bad names. Here's an interesting name. This is from the C++ standard library. In C++, if you want to know if 2 values are the same, there's actually 2 ways you can check. One of them is called equality. One of them is called equivalence. The difference is not important. What is important is there's 2 ways to determine whether 2 values are the same. Are they equal or are they equivalent? In the standard library for C++ programmers, there is a function which, given a collection, will return to you the range of values that are equivalent. And the name of that function is equal range. It does not test for equality. It tests for equivalence. One of the most important things you can do to come up with good interfaces is to be consistent. This is probably the single most vexing problem I face as an end user, either as a programmer or as an end user of regular devices. You want to be consistent in the way you lay things out, in the way you name things, in expected inputs, in reporting errors, all kinds of things. So this is an example that was sent to me a while ago. This is a picture of an automatic teller machine for Bank of America. And you can see you have 2 choices here. You can make a cash deposit, or you can make a check deposit. you can see that there needs to be a place to insert the check into the machine. There needs to be a place to insert the cash into the machine. Now, there's only two possible orders you can put these in. Either cash comes first and checks come second, or vice versa. So if you have the software team deciding what they're going to do, and you have the hardware team deciding what they're going to do, what are the chances that they will make exactly the opposite decision? And of course the answer is 100%. So the cash deposit button, here's the cash deposit hole. Check deposit, it's over here. You would not think it would be that difficult to get it right. They probably only shipped about, what, 100,000 of these machines? Apparently that didn't come out in user testing. There's a different kind of consistency. This is actually cross-platform consistency. These days, it is very common for people to use multiple devices. They're not sitting down in front of one machine. They've got maybe a desktop machine. They've got maybe a tablet. They've got maybe a phone. So they're using multiple devices to accomplish particular tasks. In some cases, the task will be the same thing. So this is another example. This happened also from a 2010 blog post. So the task here is very simple. I'm on the iOS operating system. I'm using Apple software. I'm using the mail program. I want to compose a piece of mail. All I want to do is give the command to compose mail. So on the iPad, you click in the upper right-hand corner, or you touch in the upper right-hand corner. The iPhone, it's the lower right-hand corner. And on OS X, it's right here kind of in the middle. Now, I'm not an Apple user, but there's a lot of people who are Apple users. It turns out that Luke Wroblewski is one of those people, and he points out that he is constantly reaching into the wrong place, because it turns out he uses the iPhone most of the time, so he's used to reaching down here. So when he finds himself on a different device, he's trying to reach down here, or he's trying to reach down here, which is always the wrong location. And he points out that this works against muscle memory, the idea that some actions become so ingrained you don't have to consciously think about them. But the problem is, if you have 3 different versions of exactly the same application that make you do 3 different things to accomplish the same higher level operation, that is gratuitous inconsistency. There's no good reason for that. All it does is make your users work harder at something which shouldn't even require any thought. In terms of consistency, this is what I like to think of as cross-device inconsistency. This is a photograph of my Marriott Rewards card. And in case anybody here is thinking of copying down my Marriott Rewards number and staying in hotels in my name so that I get credit for them, let me tell you, I have digitally altered the number. So that's not going to work. But thank you for the thought. Now, what I want to point out, this is a photograph of the card. Digit, 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 space, digit, 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 space, digit, digit, digit. This is not complicated. There it is. So one day, I went to the Marriott website where I decided to enter my Marriott number, Marriott Rewards number, there it is, 777 space 555 space 4. That's it. You can't type any more characters. Now, there's a couple of problems here, most of boiling down to the fact that the people who designed this interface are idiots. But setting that aside, I can't put spaces here because they count as legitimate characters. So, which means I can't literally copy what I have on the card they issued to me into the form they want me to fill out. I'm going to go out on a limb here. And I'm going to bet that anybody who is doing programming for a web-based interface could probably figure out how to discard spaces on the client before sending it to the server for validation. I'm going to guess that's probably not a taxing problem to solve. But it's easier just to count the number of digits. In terms of consistency, let's suppose you're programming in Java. So sad. You're programming in Java, and you want to know how many elements are in a container. If it's an array, there's the length property. If it's a string, there's the length method. If there's a list, there's the size method. 3 different ways to get exactly the same information. Microsoft looked at this when they were working on .NET. Microsoft said, that's so stupid. We are not going to have 3 different ways to get the size of a container when we write .NET. We are going to be different. We're going to have 2 ways to do it. So if it's an array, we're going to have a length property. If it's an array list, we're going to have a count property. Because, I mean, 2 is better than 3, right? What amazes me about this was .NET 1.0. There were no legacy users. They could not break any existing code. Now, we know exactly how this happened. Well, I'm going to guess. This is what I think happened. One team implemented one thing, another team implemented something else, and by the time they found out that they hadn't chosen the same thing, some manager said, it would be really hard and expensive, people will get used to it. And so for the next probably 30 years, people will be getting used to it. Sometimes when I point this out, people say, it's not a problem. Everybody programming in .NET, they're using Visual Studio. We've got lovely little drop-down menus, so they don't even have to remember that stuff. This is wrong for 2 reasons. Reason number 1, L and C are different letters. Reason number 2, you're not always using an IDE. .NET supports reflection. And because .NET supports reflection, this means that you can actually generate source code as your program is running, which means that now you actually have to query the type of an object to find out which interface it supports in order to know which method you want to generate the code for. So it's not true that you're always using some lovely little IDE. Let's pick on C. So this is from the C standard library. It doesn't even matter what these functions do. What I want to point out is they all operate on files, and for fscanf, fgetpos, and fseek, the file pointer is passed in first. It's the identifier for the stream. Very consistent. And if that were the end of the library, it would be great. But it turns out the library continues. fgets, fputc, fopen. Notice it's now the last parameter. I have talked to very experienced C programmers. Very experienced C programmers. People with decades of C experience. And they tell me they still have to look it up every single time they want to call these functions. This is a great quote. This inconsistency has frustrated millions of developers for more than 30 years. This is the API equivalent of the Microsoft Start button. Some interfaces really do last a really long time and are used by millions and millions, tens of millions, maybe even hundreds of millions of people. If you are ever so lucky as to be involved in the development of such an interface, you do not want someone like me making fun of you in 20 years. You probably won't care, but really, is that what you want to be known for? This is the C++ standard library. Let's suppose I have a container, and I want to get rid of all the values, all the elements with a particular value. If I have a set, I call erase. If I have a multi-set, I call erase. If I have a map, a multi-map, an unordered set, an unordered multi-set, an unordered multi-map, unordered multi-map, I call erase. It's very consistent. And you know that I would not be showing it to you if this were the end of the story. For list, you call remove. For forward list, that's actually a typo, you also call remove. Now, I am intimately familiar with the developments in C++. There are reasons for it, and the reasons are not good. I know the people involved. They're smart people. They want to do the right thing. The problem is they just never looked at it at this level. But the problem is this is how programmers look at it. Now, there is syntactic inconsistency, such as the order of parameters, or the name of the method that you have to invoke to get something done. Those are syntactic and lexical issues. But then there's higher levels of inconsistency, which are more conceptual. So from the C++ standard library, there is a function called sort. You give it a container. I'm lying, but close enough. You give it a container, and the call to sort will compile, provided that the sort can be done in n log n time. In other words, it's an efficient sort. If the sort cannot be done in n log n time, which can be detected during compilation, the call will not compile. There's a philosophy here. The philosophy behind the interface is, if we can't do your operation quickly, we won't do it at all. We will reject your code. Which means either your code compiles, in which case you know it's going to be efficient, or your code does not compile. That's nice. It means if your code compiles, you can rely on the fact that you're not doing anything grotesquely inefficient. There is also in the C++ standard library a function called binary search, which truly astonishingly runs in log n time, which is what you would expect from a binary search, if it can. Otherwise, it runs in linear time if it can't. The specification that manages to pull this off is a work of art. But the underlying philosophy is, if I can do even an approximation of what you want, no matter how inefficient it is, I will compile that program. Which means, as a C++ software developer, you're in the worst of all possible worlds. It means if you write your program and it compiles, you do not know whether it's going to run efficiently or not. And if your program doesn't compile, you don't know whether it's because there was an efficiency problem or something else. It is a conceptual inconsistency in the thinking behind the library. By the way, the calling interfaces for both of these is identical, so the syntax is not the issue here. It's a concept. Also from the C++ standard library, there is a function called sort. In computer science, every sort algorithm can either be stable or unstable. It doesn't matter what these terms mean. The point is, you can have a stable sorting algorithm, and you can have an algorithm that's not guaranteed to be stable. Turns out, sort, not guaranteed to be stable. All right? If you need stability while you're sorting, that's no problem. There's a different algorithm. It is called stable sort. Seems perfectly reasonable. Sort, not guaranteed to be stable. Stable sort, guaranteed to be stable. Seems reasonable to me. And there is a specialization of sort for linked lists. It is called sort, and it is guaranteed to be stable. Which means that if you call an algorithm called sort, you don't know whether it's stable or not. You have to go on a case-by-case basis. Inconsistent naming. I care a lot about consistency because I think it leads to difficult to use interfaces, but I want to talk about some other things as well. The next thing is to use progressive disclosure. The idea behind progressive disclosure is, given an interface, there's typically a small number of things that people probably want to do, and a much larger universe of things that they probably do not want to do, but maybe they want to do. The distribution of likelihood of wanting to do something is not uniform. So the idea behind progressive disclosure is to distinguish normal from expert level controls and to avoid overwhelming users with choices. If I go to you and say, here's 100 things, what do you want to do? The chances of you choosing the wrong one are higher than if I say, here is a list of 10 high likelihood things you probably want to do, and here's a secondary list if you want to try some other stuff. So progressive disclosure, not uncommon in GUIs. So for example, this is from the options menu, which is increasingly hard to find in Firefox, but nevertheless is still present. So you get a few options here, the things you probably want to mess with. What is my font? What is my font size? And then if you click on advanced, it gives you additional choices here. Most people just care about the font and the font size, but there is additional choices here. That's progressive disclosure. I don't give you all the information at once. I give it to you in bits. I want to point out that progressive disclosure is not the same as just categorizing things. This is an interface from a video editing program called Super. You can see things are nicely categorized, but it doesn't change the fact every choice you might conceivably want is sitting right there on that one dialog. If you are an expert, that's great. If you are not an expert, that is less great. Now, there's nothing wrong with categorization. The whole idea of dividing things and using color coding, that's a great idea. That helps people, but it's not the same as progressive disclosure. It is applicable to API design as well as user interface design. So if I have an object with a large number of methods on it, usually some of the methods are more likely to be called than others. So a number of years ago, Ken Arnold wrote an article called "Programmers Are People Too," And the example he gave was the JButton class in Java's Swing library, which he pointed out has over 100 methods. And he said, of those 100 methods, your typical user uses maybe 10. And people often get themselves into trouble by calling methods they shouldn't be calling and end up with problems that never should have arisen in the first place. So his suggestion was, instead, redesign the JButton interface so that it has a much smaller number of methods, and then for all the things that have to do with the very fine detailed look of what the button looks like, whether the edges are beveled or it has reflections and stuff like that, put those into a separate method called getExpertKnobs. And so if you called getExpertKnobs, it would give you another object, and that other object would have only the methods corresponding to that expert level stuff. But you don't get those methods unless you ask for them. And similarly, he says, for all the stuff having to do with integration, I'm not a Java programmer, so I can't give you the details, but the idea is you get the get integration hooks, and it gives you another object which has all the integration-related stuff. But the point is, most users don't want to mess with the details and use the expert knobs. Most users don't care about integration, and if they end up calling those methods, they're only going to get themselves in trouble. So the methods are still available. It's just that you have to ask for them rather than being given all of the methods at one time, and the result would be an interface that is easier to use correctly and harder to use incorrectly. Another thing that is very useful for getting better interfaces is to document things before you implement them. Fundamentally, it is based on this observation. If it is unpleasant to explain something, it is probably unpleasant to use it. So, for example, if you're trying to document something and there's surprising or underspecified behavior, if you find you have to write a lot to explain to somebody what's going on, probably that's an aspect of the interface that needs to be improved. If you have to explain what names mean, sometimes the mere act of saying, this is the name and this is what it does, and as you write it, you begin to realize this is just crazy. The name does not at all say what it does. That means the name should be changed. You will also more likely notice things like inconsistency in names and conventions and layouts. And I know that earlier today we had a talk on test-driven design. This is completely consistent with test-driven design, which is involved with having the calling interface established before you actually write the implementation at all. If you are using a strongly typed programming language, something with static typing, the type system is your friend. It is one of the best tools you have available to you. A lot of things can simply be eliminated during the compilation process, assuming you have a compilation process. So let us suppose I have this kind of an interface for declaring a date class. So here's the date. I specify the month, I specify the day, and I specify the year. This happens to be C++. I want to point out, for those of you who have not seen or worked with C++ before, I'm only going to show 4 or 5 slides, and you can take a shower afterwards, so you'll be okay. The problem here is that somebody could pass in the month, the day, and the year in the wrong order. In fact, there's a general lesson here about API design. Anytime you have an API where there are 2 parameters adjacent to one another, and they have the same type, callers could pass them in the wrong order. So adjacent parameters of the same type, if possible, if practical, is something that should be avoided, because it just eliminates the whole problem of people accidentally putting things in the wrong order. So this is an interface that is easy to use incorrectly. So what we'd like to do is provide types for the month, the day, and the year so we can tell the 3 of them apart. And in C++, what we could do is just say, great, this is about the simplest possible C++ approach. Day is now a type. Month is now a type. Year is now a type. This is the simplest possible approach, at least that I could come up with, that is type safe. And now I can say, I've got a month, I've got a day, I've got a year. So the interface now distinguishes between months, days, and years. And what that means is that if I now try to say, I have a date D that is April 8th, 2005, this will not compile. And the reason this will not compile is because 4 is not a month, 8 is not a day, and 2005 is not a year. Instead, I have to expressly create objects of the appropriate type. There's the month, there's the day, there's the year. In addition to preventing user errors, this also makes the code easier to read. Now, I want to point out for people who may be programming languages like C and C++ or other languages which make it possible to create type synonyms, that if you create a synonym, which is just a second name for an existing type, that doesn't help you any. So if I were to say day is another name for int, month is another name for int, year is another name for int, I could write this interface. This is what I call programming to make you feel better about yourself, because you haven't improved the type safety in any way. From the compiler's point of view, this is still int, 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 which means you can still make the same mistake you could make before. This can yield more readable code, but it can't prevent user interface errors. In case you want to know why I'm fixated on the 8th of April 2005, that's the day we got the dog. My wife and I, we have no kids. We have one dog. It is good to be the dog in our family. So the fact that we have created these different classes is nice, but it's still possible to use the interface incorrectly. Remember that a month would take any integer. Last I checked, there's only 12 months, at least in modern calendars. So somebody could still say month m minus 4. Now, you might say, who's going to say month m minus 4? Probably no one is going to do that deliberately, but it might not look like minus 4. It might look like x minus y, when it should have been x plus y. Or it could have been f plus g. In other words, it could have been an expression and someone made a mistake in the expression. So it's not something as silly as typing in the wrong number. Well, we'd like to be able to prevent that problem, and it seems like since there's only 12 months, we should be able to do that. So let's make month a real class. Let's declare 12 immutable month objects, and let's limit month object creation to those 12 values. In C++, it looks something like this. And the result now is that this won't even compile. So that's nice. Didn't take very much work, fit on one slide. So instead, what I can say is the month m is month : April, and now I can create a good date. That's nice. Not very much work. Eliminated a whole class of mistakes. Uh-oh. Now I can create the day 71. Now that's unfortunate. Now, to be honest, if you want to fix this problem, you can. It's not a big deal. Your month class can serve up day objects, which means you could not create invalid month-day combinations, but then the month object would have to know what year it was. It gets complicated. Now, whether the effort and the complication is worth the trouble depends on the cost of an invalid date in your software. What I want to get across here is the idea is that when you design an interface, you should always ask yourself, what kinds of errors might people make in this interface? And then you should ask yourself, okay, given the errors that they could make, what actions can we take to prevent them? Once you've done that, then you can say, all right, these are the errors that people might make. This is the cost associated with the errors being made. This is how we can prevent the errors. This is the cost associated with preventing them. Now you can make an engineering or a business judgment as to whether the difficulty of implementing the prevention is worth it in terms of the kinds of mistakes that will be prevented. What I find is that in many cases people just say, oh, here's an interface, and they don't think about it any further. I am encouraging you to analyze whether the mistakes can be prevented. Even constraining values can lead to a false sense of security. This is from a couple of years ago at the Lonely Planet website. They've got a drop-down box for days, very common. The nice thing about drop-down boxes is that they are intensely irritating and they don't actually help you any. Notice that I can specify June 31st, which, at least on my calendar, is not legal. What's really nice about Lonely Planet, and I don't know why I was at Lonely Planet, but I was trying to get some work done. And then I began to notice that if you want to fly somewhere, they've got a calendar widget. If you want to rent a car, they've only got a drop-down. And if you want to get a hotel, then they've got both a drop-down and a widget. So the nice thing about that is it turns out they fixed this in the meantime, but as of 2 years ago, the nice thing was that depending on whether you wanted to fly somewhere, stay somewhere, or drive somewhere, you had to specify your calendar options in 2 different ways, which leads me right back to consistency and muscle memory. The last thing I want to mention as a specific piece of advice is to avoid over-reliance on string. String is what is known as a type sink. There is rarely something in software like a string. Strings do not exist in the real world. What exists in the world are names, passwords, addresses, cities. Strings rarely exist in the real world. File names are fundamentally different from customer names. The fact that they are sequences of characters is fundamentally irrelevant to their meaning. And though there should both be really different from regular expressions, which is also a sequence of characters with a very different meaning. A printer name should be really different from a driver name. I did not make up this example. One of the people I was talking to at a training course one time talked about how their company managed to waste 2 engineering days trying to figure out why their software was not behaving properly, and it's because they used a string for the printer name and a string for the driver name, and they passed in the wrong string value because they were almost identical. On Windows, they differ only in the extension. Once you know what a string represents, you can do things like validate it, make sure it's got legitimate values. You can print it properly. It's really different. The way you print or validate a file name is fundamentally different from printing a customer name. It is not the case that strings are strings. Rather than using strings in your APIs, you should be using something that's descriptive about what they stand for. So I want to get back to this idea that the number 1 rule is to make interfaces easy to use correctly and hard to use incorrectly. That's the high-level idea. And some of the specific things that we talked about how you can achieve this idea is to adhere to the principle of least astonishment, so avoid gratuitous incompatibilities with the surrounding environment, choose good names, strive for consistency whenever you possibly can, document your interfaces before you implement them, employ progressive disclosure to avoid overwhelming users of the interface with too many choices. And when it's relevant and you have the right programming language, introduce types to prevent these errors. Consider explicitly defining all the possible values for the type. And avoid over-reliance on string. So that is my advice for the most important design guideline. Are there any questions? Yeah.
Just out of curiosity, what would be your comment on the fact that Windows has the 3 action buttons on any window in the exact opposite order as the Mac OS does? Because this is something that's driving me personally out of my mind.
Okay, so the question is, do I have any comments on the fact that on Windows you've got 3 buttons that are in exactly the opposite order as the corresponding 3 buttons on Mac OS? In this particular case, you have companies that are competing with one another. It is unfortunate from a user perspective, but in this case, there's not any one entity designing both interfaces. So it might be a gratuitous inconsistency, but it also might be a deliberate choice. So I feel badly for you. I can see why it would be frustrating. But I don't think it's because somebody sat down and said, we're going to deliberately annoy our users. Any other questions? Then thank you very much for listening at the end of the conference.